Hey, welcome to lesson 2 in your transformations unit from your workbook, your Absolute Value Publications workbook. Okay, we have looked at lesson 1 already, which was horizontal and vertical translations. This is also horizontal and vertical translations, but what's different now is we are going to focus on, so they give you some summary notes here, but we are now going to focus on specific functions, not just f of x, but actual functions like in this first example, x to the 4, and a linear function, and an absolute value function. Okay, so not just f of x anymore. All right, so let's get to work on example 1 and jump right in. Okay, hopefully you remember everything from lesson 1. Okay, write the replacements for x and y or y, and describe how the graph of the second function compares to the graph of the first function. So let's look at what's happened here. What's different? Well, plus 3 is there, which wasn't there before. So let's maybe move that back over with the y. It's not with the x, because if it was, it would be inside those functions. So as a result, that 3 should probably be over here with the y, because it's not with the x. Okay, if it was with the x, it would look like this, inside the function, like that. Okay, with the 4 on the outside. It's not that, so we're going to move it over, and now we can see that y was replaced with y minus 3. Okay, so how does the graph move? Well, the graph would have been vertically translated up 3 units. Okay, there's our replacement, and it moved up 3. All right, let's look at b here. Okay, comparing this equation to this equation, it looks like, now don't let that minus 3 throw you off, okay? There was a minus 3 in the original equation, so that has not changed, all right? But what has changed is instead of x, we now have x minus 1. So our replacement was that x was replaced with x minus 1, which means, as far as the graph goes, that it would have moved to the right 1 unit. Okay? All right, now you guys try C and D, and then pause your video, and we'll check back in a minute. Okay, on part C, I would first move that 2 over with the y by subtracting 2 on both sides. It's not with the x, so it has to be with the y, so that we can determine our replacements of y being replaced with y minus 2, x with x minus 6. Therefore, we're moving up 2 and right 6. Good job. Okay, part D, x was replaced with x plus 1. So therefore our graph moved left 1. How'd we do? Okay, let's look at example 2. Write the replacements for x and or y, and hence the equation of the image. So backwards 1 again, they're giving us what the translations are. We need to come up with what the new equation looks like. So I would suggest, and they tell you in the equation as well, to write the replacements. So let's read this. Y equals x squared. After a horizontal translation, so horizontal means x is going to be replaced with 3 units to the right, so that would be x minus 3. Okay, so now what we're doing is taking our original equation, we're scooping x out, and we are replacing it with x minus 3. And there we go, that would be our answer. All right. Let's look at the next one. Y equals 10 to the x. After a vertical translation of 2 units up. Okay, vertical means y is going to be replaced with. Now, 2 units up would mean that y is replaced with y minus 2. Okay, so let's take our original equation, y equals 10 to the x. We're scooping this time y out and putting in y minus 2. Do we need brackets? Probably not. Okay, so we'll get rid of those brackets. Sorry about that technical glitch. Okay, so we replaced y with y minus 2, or we could isolate y and rewrite that as y equals 10 to the x, and then add 2 to both sides, and we would have plus 2 on the right-hand side. There we go, that gets rid of that. Either one of those answers would be fine. Okay, you guys try part C, and then we'll see if we get the same answer. Pause your video, Okay, so the replacements would be x gets replaced with x plus 4, y was replaced with y plus 3, and we take the equation and we do those replacements, and we should have y plus 3 equals the square root of x plus 4. And that would be fine as an answer. Or we could also isolate y by subtracting 3 from both sides to get y equals the square root of x plus 4 and then minus 3. Note the minus 3 is not under the square root, so you can't add the 4 and the negative 3. Okay? Okay, let's look at the next page. Okay, example number 3. The function represented by the thick line is a transformation of the function represented by the thin line. Write an equation for each function represented by the thick line. Okay, so we're going from the thin to the thick line. Okay, they're giving us the equation of the thin line. Let's first figure out how it moved, okay? And an easy point to figure out is the vertex point. Started at 0, 0, and it looks like it moved 1, 2. Now is our scale each square is a unit? Yes, it is. So it moved 2 units to the right, and then 1, 2, 3, 4 units down. Let's write that down somewhere. So right 2 and down 4. Okay, so the replacements for each of those would be, right 2 would be x is replaced with x minus 2, and y for down 4 would be replaced with y plus 4. Okay, so let's take our equation, y equals the absolute value of x, and do those replacements. In for y, y plus 4, in for x, x minus 2, and that would be fine as an answer. We could also subtract 4 to the other side. It does not go inside the absolute value, it goes outside of it, and you'd have the absolute value of x minus 2, and then minus 4. All right, great job. Now I'm going to do B with you, and then you guys are going to do C and D as well on your own. But B is a little bit tricky, so that's why I'm going to do that one with you. Figuring out the translations here is the hard part. So, because we don't have a nice vertex point like we had before, sometimes it's easier to do with the asymptotes when you have a rational function like this. So let's look at what our original asymptotes were for the thin line. Okay, so it looks like our graph is not crossing the x-axis, okay, and it's also not crossing the y-axis, which means our asymptotes are the x and y-axes. So we could use this origin point and then figure out where that moved to. Let's draw in the asymptotes for the new thick graph. So it looks like our vertical asymptote is running right here because our graph doesn't cross that line. And the horizontal asymptote is running here. So there is our intersection of those two asymptotes. So that's what we're looking at, is where this intersection moved to get to here. And it looks like up to and right 1. Let's write that down. Up to right 1. Okay, why don't you guys finish this one up, figure out your replacements, and then use this equation, y equals 1 over x, to do those replacements. Okay, so replacements should be y goes to y minus 2, x goes to x minus 1. Scoop those out in our equation, and we would end up with y minus 2 equals 1 over x minus 1. That would be sufficient, or you could add 2 to the other side to isolate y, and this could also be a form of the equation that would be good. All right, so on C and D, look for a key point to figure out the translations, and then do the replacements in the equation. So you guys go ahead and do C and D, and we'll check back in a minute. Okay, so part C, we should have ended up with y plus 4 equals f of x, or isolating y equals f of x minus 4. The graph moved from thin to thick line, moved down 4, therefore our replacement was y gets replaced with y plus 4. Okay, part D, our graph moved up 4 and left 3 to get to the thick line, so our replacements were y minus 4 in for y and x plus 3 in for x. So our equation could be y minus 4 equals f of x plus 3, or isolating y equals f of x plus 3 and then plus 4. Okay, let's look at example 4, our last example. Woohoo! Okay, so y equals the square root of x is a radical function, what vertical translation would be applied to y equals root x? So the translation image passes through 16, 7. Okay, this is a challenging question, so wake up if you're not awake yet. Okay, what vertical translation? So we don't actually know the translation, and we don't know the original point. We know a point on the transformed function, but we don't have the equation for the transformed function. Okay. So what vertical translation? Let's say we're going to call that k. Okay. So we are going to take y, because it's vertical, and we're going to replace it with y minus k. All right, so in here, this is going to become y minus k equals root x. Okay, some unknown vertical translation. All right, but now that we have the transformed function, this point, which was on the transformed function, can now be subbed in. Any point on a graph, if you have the equation of the graph, can be put in for x and y. So in for y is going to go 7, in for x, 16. Okay, we're going to simplify this. 7 minus k equals root of 16, which is 4. Okay, we're going to isolate k. Now I like k to be positive, so I'm actually going to add k to the other side. Okay, so that we then have 7 equals 4 plus k. All right, one more step, subtract 4 from both sides, and we would have 3 equals k. Now let's put that back into our equation there. So it would be y minus, and our k is 3, equals root x. By doing that, we can better see what the vertical translation was. So in other words, y was replaced with y minus 3. So what kind of translation is that? That would be up 3 units. There we go. Okay, you guys try part B, and then we'll check and see if we got the same answer. Okay, tricky 1A. So horizontal translation, that means this time we're replacing x with x minus h. I used h just because that's what we typically use in this unit, but it can be any letter. So in for x in our equation, y equals root x, we put x minus h. Okay, once we do that, we have the transformed image in which this point is on. So in for y goes 8, and in for x goes 17. In for x, not h. Now we've got to go about solving for h. So we square both sides, get 64 equals 17 minus h. I don't like a negative h, so I add h to the other side, then subtract 64 to the other side, and I get h equals negative 47. Now before we say what horizontal translation that is, let's sub it back into our equation where we had y equals square root of x minus h, in which case we'd have minus and then negative 47, which means x plus 47. Aha, so that means our graph has actually been moved left 47 units, okay, in order to go through that new point. And there we go. Translations all finished. Hopefully lessons 1 and 2 assignment goes awesome for everybody. And we'll see you in our next video lesson on lesson 3.